start polynomials. Now, let x be a variable, n be a positive integer, and constants. Then f of x is equal to this is a polynomial of degree n. The highest degree, all of you are familiar with the term polynomial. You know the difference between rational expression and a polynomial, right? In lower classes, you would have got clear idea about it. So, n should be a non-negative integer. Exponents have to be positive. Now, we are going to deal with properties of the polynomials. Now, polynomial can be monomial or binomial. For example, when I write like this, it is a linear polynomial because the highest degree of the variable is 1. But it is a binomial because it has got 2 terms. When I use the term monomial, binomial, trinomial, so the terms can be having, the terms are separated either with a plus or minus sign. But when I say polynomial, linear polynomial, quadratic polynomial, it is with respect to the degree of the highest degree of the given variable. Now, you know very clearly, linear polynomial, suppose I am writing this, it's a polynomial. If a linear polynomial is equal to 0, graphically it represents a line. In previous classes, you must have even traced graph on this. So, linear polynomial always represents a line graphically. Now, we will just go higher to the quadratic polynomial. Quadratic polynomial. Now, we are going to deal with the quadratic polynomial. We call it quadratic polynomial because the highest degree is 2. Now, if we trace graph on this, we are giving values for x, corresponding y values we are writing. Now, we will just take the points under with minus 2, 0. Minus 1, minus 5. It will be somewhere here. Okay. 1, minus 4, 16. Minus 4, 16 will be somewhere here. So, if you trace, you will be getting a curve like this. See. Okay. Now, this is representing a parabola. If the quadratic polynomial is of this form, it will give a parabola which opens upwards because the quotient of x square is 1. If the quotient of x square is negative, in that case the parabola will open downwards. So, now we will just deal with the different characteristics related to this. X square minus 2x minus 8. If you just factorize, you will be getting minus 8. So, it will be giving you x minus 4, then x plus 2. So, x will be equal to 4, x is equal to minus 2. Now, in the graph, you see this parabola will cut x-axis at 4, 0, this is 4, 0, and other point is minus 2, that is minus 2, 0. So, zeros of this quadratic polynomial, 4 and minus 2. That means, only when the graph cuts the x-axis, they are not concerned about y-axis. When the graph cuts the x-axis, You call these points where it cuts the zeros of the polynomials, the coordinates being 4, 0 and minus 2, 0. And if you are just doing algebraically, you call this as roots of this quadratic equation. Now, see, now we will see the different categories in this. For example, if you take y is equal to 3 minus 2x minus x squared. If you factorize, 3 into 1 will be 3, 3 minus 3x plus x minus x squared, 3 will be common, plus x into 1 minus x. So x is equal to 1, x is equal to minus 3. But when you trace, this graph will cut it at minus 3 and 1. And it will be opening downwards because quotient of x square is minus 1. Now, any quadratic polynomial is of the form plus bx plus c. So, if it is equation, ax square, it's a function. So, y is equal to ax square plus bx plus c is equal to 0 is quadratic equation. F of x is equal to